Today we are going to be going over some exponent rules, specifically negative exponents. And so last year and the year prior we've dealt with terms with exponents and even common bases. And so here's an example, 6 squared over 6 to the fourth. Well, there's two ways to go about doing this problem. The first way is to write out the number of sixes that we have. We have 2 sixes on top, and we have 4 sixes on the bottom of the fraction. And what we can do is we can cancel out 2 of the 6's on top and 2 on the bottom. And you can see that no 6's are left on top. Well, when we're canceling things out, the number we're left with is really just 1. And 1 times a number doesn't change anything, it just is 1. But on the bottom, we're left with 6 to the second power. Well, if we wanted to multiply that out, that'd be 1 over 36. Well, there's another rule, and the other rule is that you can subtract the exponents when we have the same base and we're dealing with division. Now, the way we do that is we rewrite it as 6 to the second minus 4. And this is all on top of the fraction when we use this method. So I'll just show this as a fraction as over 1. And when we do that, we're left with 6 to the negative second power, and I'll keep it as a fraction over 1. So typically when we use this method, we take the bottom away from the top. Now, here we're left with 6 to the negative second power. Well, what I wanted you to see is that if we have a negative power, all it is the reciprocal of a positive power. So we can get the same answer by using the rule. And the rule is this. If you have negative exponents, you switch their location in the fraction. That's called taking the reciprocal. So we just take these 6's and move them to the bottom because they're negative on top, and then we end up with the same answer we have up top here. We end up with 1 over 6 to the second. And that's the concept that we're going to end up using today. When we have negative exponents, we're going to take their reciprocal and they become positive. Well, there's another type of number that we're going to end up dealing with here, and we're going to use that same rule. See, if we take that rule and we subtract the exponents, 2 minus 2, we end up with 0, m to the 0 power. Well, what is that? Well, let's see here. Let's go ahead and rewrite this without exponents in an expanded form. So m squared is just m times m. And then down below we have m squared is m times m. And if I use that rule of canceling out common factors, these m's would cancel out. M divided by m is going to be 1. Well, another m divided by m is going to be 1. Well, if you multiply these two 1's, you end up with 1 over 1. So that tells us that m to the 0 power is equal to 1. And that's going to be another rule that we're going to deal with. So those are the two big rules that we're going to learn today or use today. And we'll just try a bunch of problems and use those rules. So negative exponents, we take the reciprocal and they become positive exponents. If we have any number, m or an x or even a 2 or a negative 5, as long as it's in parentheses, and we'll talk about that, to the 0 power, it equals 1. Well, let's take a look at some different problems here. Here's 3 to the negative third. So if you had this problem, what you would want to do is write this as a fraction and then just take the reciprocal of these negative exponents, and then they become positive. And so the common mistake is people are going to want to just say, oh, this is negative 27, because 3 times 3 times 3 is 27, and there's a negative sign right here. But no, it's not the case. It just means take the reciprocal. So it means 1 over 3 to the third. And then you could go ahead and multiply these numbers out, and that gives us 1 over 27. So it's not necessarily a negative number. The negative number comes into play when we have a minus sign in front of the number, not the exponent. The exponent just means take the reciprocal. Now let's take a look at the next one here. Same sort of thing, differences. Now we do have a negative number. Well, what's the answer? Let's see here. Well, first of all, let's take these exponents and these two negative 2's, and they go down below, and then they become positive exponents. That's the first thing you always want to do is when we've got those negative exponents, let's make them positive. Now notice that the negative 2 is inside the parentheses. So what that means is that negative 2 is being multiplied that 4 times in this case, because that's what the exponent says. And so here we have 4 negatives. Since it's an even number of negatives, this does make a positive number. So this would be 1 over 16 for our answer. Well, we have another scenario, though. Here, same problem, but no parentheses. Notice there's no parentheses here. So what this means is, first of all, let's go ahead and write this as a fraction. Now, this is the same thing as saying negative 1 times by 2 to the negative 4th power. So 2 is to the negative 4th power, but not the negative 1. That's what this means, the opposite of 2 to the negative 4th. Exponents have to go first. That's what order of operations says. So when we do this, we're going to leave that negative 1 there, and we're just going to move these 2's down below. So what this becomes is just a negative 1 over 2 to the 4th. And as we saw before, when we multiply 4 2's together, we end up with 16. But the answer is negative this time. And the reason is because the parentheses were not around the negative 2. So it's not negative 2 being multiplied 4 times. It's the opposite of 2 to the negative 4th. Any negative exponents go to the bottom. Negative numbers, notice they stay where they're at. They don't move. Well, here's another example. And, to put that into perspective, let's try that again. I'm going to change this problem to negative 2x to the 0, y to the negative 4th, because I want to use that concept again, because that's a common mistake, is when people see a negative number, they take the reciprocal and they think it's positive, but that's not the case. It's only the exponents that we take the reciprocal of. So these y's are going to go down below. And we also have something else we can simplify. What does that x to the 0 make? Hopefully you said 1, and that's what it makes. So whenever you see any number to the 0 power, it's just 1. Now notice the negative 2 didn't change. That stays where it's at. It's just the y's that got brought down below. And they become positive exponents, and there's your answer. So these problems can go pretty quick. Anything to the 0 power is 1. Negative exponents switch locations. Well, here's another example, same type of problem. Here, this time we have some positive exponents and some negatives. Notice the negative exponents are in the middle, so sometimes people get confused here. Well, don't be confused. Anytime you have negative exponents, those get moved. Positive ones stay where they're at. Positive numbers, negative numbers, those stay where they're at too. It's only negative exponents that change location. So the 2y to the third is going to stay on top. The x to the negative second, that one down below. And the reason why we did that is so that we could make those exponents positive. And that's our answer. Well, here's another scenario. It looks a little different. What's different is that we now have a fraction. Well, we got negative exponents in the bottom of the fraction. No fear. All we're going to do is just take their reciprocal. Let's move these x's down below. Let's move these y's up top. And now we've taken the reciprocal of both. So now they're both positive. So what we've got is 2y to the second, and down below we've got 9x to the third. Notice, the only thing that changes when you take the reciprocal is those exponents, and that's what we want to do. We want to make the exponents positive when we're simplifying, and that is our answer. Another scenario, we've got some negative exponents on the bottom this time, and we've got an x to the 0. Anytime you see anything to the 0, cross that off, put a 1. 1 times a number is not going to change anything, so you don't even need to worry about it. Well, here's the negative exponents. Let's move those to the top. And we don't have a fraction anymore. That 3 stood where it was. The y to the 4th stays where it is. And that z to the negative second is now a z to the positive second when it's all on top of the fraction. And there is our answer right there. Well, another scenario. A little bit different than the last, and again, when we have negative exponents, that's all that moves. Negative numbers and positive numbers, those stay where they're at. Positive exponents, those stay where they're at. It's just these negative exponents that we're going to switch directions. So the x's go on the bottom, the c's go on top, and then you just rewrite your answer. So notice, nothing changed. If this were a negative 2, it would not move. It's positive 2, it does not move. It's just negative exponents that are going to move. So we'll stick that c to the second. Y, those are the numbers on top. See the 2 and y, those stayed where they're at. C to the negative second is the one that moved. And then the x to the negative 4th, that goes down below. Well, we still got these a's, though. So a to the third, those stayed where they were. And x to the negative fourth went down below. Now it's a positive 4. And there's our answer. So that's the first set of directions, just to simplify. We've got 2 more sets of directions to go.